All right, guys, I just want to show you 11A and 11C. All right, here we go. So you read this whole thing, and it wants to know, assuming it operates at full capacity for 8,000 hours per year, how many kilowatt of electricity can be produced by the plant in a year? When it says the capacity is 12 megawatts, that 12 megawatts is at any time it's running, right? So if it's at full capacity for 1 second, then it's producing 12 megawatts for 1 second. If it's running at full capacity for 2 days, then it's running at 12 megawatts for 2 days. So that is at any given time. So if we know it's running at 12 megawatts at any time, and then we multiply it by hours, 8,000 hours, we get megawatt hours. We don't want megawatt hours, we want kilowatt hours. So what we do is we convert this to kilowatts, then multiply the kilowatts by the hours, and that's how many kilowatts per year. So for megawatt, we're going to do 1 times 10 to the 6 watts over 1 megawatt. That cancels megawatts. Now I'm going to convert to kilowatts. That's up here. So 1 kilowatt is 1 times 10 to the 3rd watts. So watts cancel, and now I'm going to have kilowatts. And that is 12,000 kilowatts. All right? So that's how many kilowatts 12 megawatts is, right? So now if we take 12,000 kilowatts times 8,000 hours it's running for 1 year. So if it's running at full capacity for 1 year, which they're telling us is 8,000 hours, 8,000 times 12,000 is 1.2 times 10 to the 11th. Oh no, that's the next. That's number 10. Jeez. Sorry, I'm looking at my key over here. 9.6 times 10 to the 7th kilowatt hours per year. Again, labeling units, showing, canceling, labeling, answer. Okay, so that's A. All right, now we want I thought that would be faster. It's not. All right, it's almost faster to just do this. Kill that. Whoop, that's something different. That's for chem. Here we go. Part C. Now this and this. Okay, here we go. So assuming the electrical energy needs do not change during the 25-year lifetime, what would the cost of the community be for the wind farm, the wind turbines over 25 years? All right. So we calculated in 11B, so 11, the one above it, it was 2.4 times 10 to the 7th kilowatt hours. That should be a bigger W, sorry, per year. Okay, so that's how many kilowatts per year the homes, 3,000 homes needs. 3,000 homes need that many kilowatts per year. Okay, if we multiply that by 25 years, all right, so that cancels the years, you get how many kilowatts the 3,000 homes are going to need in 25 years. So that is 6.0 times 10 to the 8 kilowatt hours. Okay, and now we want to know how much it's going to cost. So we need to produce that, right? And 10 turbines, and they're 3 million each. So that's a cost of $30 million. $30 million for the 10 turbines. So if the 10 turbines cost $30 million and we want to divide that by 6.0 times 10 to the 8th kilowatt hours. Why? Because it says dollars per kilowatt hours. After they purchase those turbines, based on how many kilowatt hours they need for 25 years, you take the cost of the 10 turbines, divide it by how many kilowatts you need for 25 years, and that's going to give you 0.05 dollars per kilowatt hour. All right, so 5 cents per kilowatt hour. There you go. So I'm going to kill this video. I will post the picture of the answer key a little bit later, or like I think I already like scheduled it. I hope you guys are doing well. And don't forget, you got the free response due Monday, Unit 6. All right. Any questions, text, email, message through any of the stuff we're using. All right. Have a good weekend.